All right, chapter 4 deals with weathering and soil formation. Um, I know it's not super exciting for some of you, but you can start to think about all these rocks on our planet, and looking at these pictures. We're looking at a lot of changes that happen through our rocks. Now, a couple of things that we want to look at is trying to identify certain terminology. So in this case, I think I'll pick one of these fun colors. Ice wedging. That's one type of mechanical weathering where ice gets into the rocks, uh, freezes, and it cracks. Pressure release. It's another word for that is like onion skinning. It kind of peels off like the skin of an onion, so the pressure builds up and it breaks off like the layers of the onion. Um, then there's plant root growth. It's just like it sounds. Plant have roots and they grow into the rock and they split it apart. So that one goes there. And then abrasion. That's probably the one that most people see along the rivers or lakes where the waves and the water break down the rocks into smooth surfaces. Um, then there's these pictures, like you see this picture right here. Oops, maybe I should actually not have a pen anymore. Let me get rid of him. Um, Now this guy right here, he looks like a layer has been broken off. These rocks right here, they are by abrasion. This one right here, you can see it's been split because ice had gotten between that rock and broke it. And this one obviously is our plant root growth because of the roots growing into the rock. What kind of mechanical weathering is in this picture? Well, if you look here, we got some plants and we got some roots. So I'm going to say it's probably plant root growth. This one right here, the layers kind of came off, so it looks like a pressure release. This one was abrasion by the wind. You can see that it's been rounded and smooth. And this one, I think the snow gives it away, but you're looking at, what is it? What is it? It is, yeah, I think I heard you, ice wedging. So that's all that mechanical weathering. Now with chemical weathering is when the water mixes with the chemicals on the rocks and they actually kind of create a little acid, and it dissolves the rock. Like this picture right here uh, is a picture of a monument, and the monument, it wasn't like that when they put it out there. There weren't these dark streaks going through it. So dissolving is one type of mechanical weathering where the chemical mixed with the water and it made a weak acid. Sorry about that, Mrs. Stewart was walking down the hallway and talking kind of loud. Um, Rusting is another mechanical weathering. I know you can't really see this down here, but so I'll move them over a little bit. But rusting is when oxygen and water mix with the iron in the rock, and it makes an iron oxide, which is rust. If you ever left a bike outside, have you ever seen a car sitting out in the field and it's all rusty? This is the reason why. Now, if you look at here, this would be an example of what kind? Rusting or dissolving? Uh, Dissolving? Probably. Now this one I'm going to say is rusting. It may or may not. Oh, there's my attendance for the day. Um, but rusting, this one is just the coloration of the rocks too. So now there's three reasons why we have chemical weathering happening at different speeds. One is obviously if there's more area of the rock, that there's more surface exposed to the wind and the rain, you're going to get more weathering. It's going to happen faster. Uh, the rock, what it's made out of, if it's made of a soft rock, it's going to go down and weather faster. If it's a harder rock, it's going to take a little bit longer. Now climate, if it's a hot and wet climate, things are going to break down faster. If it's a cold and dry climate, it's going to take longer. Now, if it's cold and wet, it's going to be in between. If it's hot and dry, it's going to be a little bit less as well. So depending on what kind of climate that you're in, is going to determine whether or not it breaks down faster or slower. Now, this one I just threw in as a review from the last chapter, but weathering Here we go. You see some of the rocks getting broken down. It rains. Uh, Here comes our rock. It's going to start to tumble down here pretty soon. Um, Oops, somebody kicked it. Breaking down into smaller pieces. And as it gets down to the bottom, um, here's an activity. Freeze and thaw. I wonder what that is. Is that a chemical or is that physical? It's probably physical because it happened in nature. Onion, that's physical. Tree roots, uh, that's physical. Animals burrowing, that's biological. Acid rain, chemical. And people walking on it, that is, should we check to see if we're right? Never done that one before, so, yep. Tree roots were biological. Duh, trees are living. There we go. Um, and how does dirt form? I'm going to ask you to go into your book. There's a visualization on how soil forms. Um, I don't know if this will get us there or not, but I think it might. Taking some time here. Simulations, visualization, soil formation. There we go. Excuse me. And I think I'm going to move this up just a little bit. So when we were talking about how soil forms, at 0 years we just have basically rock. But after about 10 years, that top layer breaks down into smaller pieces due to weathering, and we get a horizon sea layer. After about 100 years, some of that horizon sea actually breaks down into some organic matter. So you actually have some soil there where plants can take root and start to grow. Over time, about 1,000 years, you get a layer B that kind of forms in between A and C. It's more of a clay-like layer. And after about 10,000 years, you actually have enough dirt there that can grow plants. So it takes about 10,000 years. That is a crazy amount of time. So let's see if I can find it back where we were. Oh, here we are. Weathering according to organic processes move all the factors that affect the soil. Well, let's see, probably plants, maybe the climate, maybe the kind of rock, maybe the organism, maybe the landform, and maybe time. Let's see. Oops. I forgot to say it was all of them. Every one of those things affects the weathering of the land. And here are some pictures of just different horizons. You can see the different coloration right here. You got the topsoil B, C, and here's your rock layer right there. And here, just, whoops, what happened there? Just horizon A, lots of organic. It's dark, it's called topsoil. Horizon B, brownish, reddish clay mineral. Deepest layer though is kind of yellowish. And then you have your rock layer, which is down below. Climates and different areas that will affect soil. And when you get to this, you'll have a link to this on my teacher page, but you can definitely view this. My time's running out. Moving on. Nothing. Oh, here's something. That was the bell. I should be picking you guys up, but if you start clicking on these things, you can show where the polar and the temperate soils are, where the tropical soils are, where the desert soils are, and volcanic soils. Now, that's up to you to go check and look and see where all these different types of soils, you can kind of see where right here in the temperate area itself. So let's go back to the PowerPoint. I think I'm going real far. I'll get back to this. We'll start another one soon. Otherwise, get as far as you can on this, check out some of those things, and I'll catch you later.